morning, students. As we have started with a new chapter, that is surface chemistry, and in the previous link you people must have studied about adsorption, types of adsorption and adsorption isotherm. That was the first part of the chapter. Now today we are going to begin with the second part of the chapter, and the first topic that we are going to discuss under this is catalysis. Now the first thing that we need to know, what do we mean by catalyst? Now these are the substance which alters the rate of a reaction without actually getting disturbed. So what are catalysts? Substances which alters the rate of a chemical reaction. Second thing is without undergoing any change in itself during the chemical reaction. Now these are known as catalysis, and the process by which a catalyst work is known as catalysis. Now this catalyst is of two types. One is your positive catalyst and the other one is your negative catalyst. Now this classification, that is positive and negative catalyst, was done on the basis of mechanism of catalysis. Now what do you mean by positive catalyst? Positive catalyst are the catalyst which enhances the rate of reaction. Whereas negative catalyst are the catalyst which decelerate the, or you can say decreases the rate of reaction. These positive catalysts are also termed as promoters. They are also known as promoters because they enhances the rate of reaction. Whereas these negative catalysts are known as inhibitors because they decreases the rate of reaction. And the next classification is on the basis of phases, that is different phase, under which it is categorized into two parts. One is homogeneous and the other one is heterogeneous. You all know homo means similar and hetero means different. So on the basis of different phase present in a chemical reaction, it is categorized into homogeneous and heterogeneous. Let us first talk about homogeneous catalyst. Now what are homogeneous catalyst? If the catalyst is present in the same phase as the reactant, it is known as homogeneous catalyst, and this type of process is known as homogeneous catalysis. So what is homogeneous catalyst? If the catalyst is present in the same phase as the reactants, that is known as homogeneous catalyst. What is heterogeneous catalyst? If the catalyst is present in a different phase than that of the reactants, that is known as heterogeneous catalyst. We'll see with the help of an example here. If we talk about formation of sulfur trioxide, it is done by the process of oxidation of sulfur dioxide. So what is the reaction? SO2 plus O2 will give you SO3. Let us balance the reaction here. 2 and 2. Here in this reaction, the catalyst which is used is nitric oxide. The catalyst which is used is nitric oxide, and you can see all the reactants, the catalyst and the product is present in the same phase. Let us see it again. Oxidation of CO2 leads to the formation of sulfur trioxide. And in this reaction, the catalyst which is used is NO. What is homogeneous catalyst? It is a kind of catalyst in which all the catalyst, whether it is reactant, product or the catalyst, they are present in the same phase. That is known as homogeneous catalyst. Let us take another example. If we talk about hydrolysis of sucrose, C12H22O11, that is your sucrose, when it undergoes process of hydrolysis, it leads to the formation of fructose and glucose. And here the catalyst which is used is H+. All the reactants and product as well as the catalyst is present in aqueous form. Sucrose is also present in aqueous form. H2O is present in the form of liquid. Fructose and glucose is also present in aqueous form, and the catalyst is also present in the aqueous form. So the catalyst in a reaction, if it is present in the same phase as the reactants, that is known as homogeneous catalyst. Let us talk about heterogeneous catalyst. If we take example, the most common example is your Haber's process. Haber's process, that is for the manufacturing of ammonia. Let us write down the reaction. N2 plus 3H2 will give you NH3. Let us balance the reaction. 2NH3 here. Here the catalyst which we are going to take is Fe, that is iron. In this case, the reactants are present in gaseous state. Product formed is also present in gaseous state, but the catalyst that we have taken is Fe is present in the form of solid. So, what are heterogeneous catalyst? The catalyst which is present in different phase than that of its reactant is known as heterogeneous catalyst. Now we are going to talk about theory of heterogeneous catalysis. Now this was basically based on adsorption theory, and there were two concepts given. The old concept, according to the old concept, it was said that if the reactants are present in the gaseous state, they are adsorbed on the surface of the catalyst, due to which the concentration of the reactant molecule increases, and which leads to the enhancement of the rate of reaction, or which leads to the increase in the rate of reaction. This was the old concept. That is old concept of adsorption. We need to discuss about the modern concept of adsorption theory. Modern concept of adsorption theory. Now, according to this concept, it was said that there are certain steps. The first one is diffusion of reactant molecules towards the surface of the catalyst. Let us see this with the help of a systematic diagram. Suppose here we are having a catalyst, and on the surface of the catalyst there are free valencies, or you can say cavities or space. Now what happened? This is the surface of the catalyst with free valencies, and we are having reactant here, A plus B. What are these? These are the reactant molecule. The first step says that diffusion of the reactant molecule towards the surface of the catalyst. The reactant molecule will diffuse towards the surface of the catalyst. When it will get diffused on the surface of the catalyst, it will lead to the process of adsorption. Adsorption of the reactant molecules on the surface of the catalyst, and it will form loose bond with these voids or space which is present on the surface of the catalyst. This is your catalyst having space on its surface or binding sites. Now this reactant which we have taken will bind to the surface of the catalyst by loose bonds. After that, what will happen? It will lead to the formation of an intermediate product. After this, there will be a formation of intermediate product. Let's see how that intermediate product will be formed. Catalyst with active sites or free valencies on its surface. A and B, this loose bond will now convert into chemical bond. And this is an intermediate product. Intermediate product is considered as unstable in nature. And due to its instability, what will happen? The process of desorption will take place. That is, desorption of the product molecule from the surface will take place. Why it is so? Because this is considered as unstable in nature. That means these active sites or these free valencies are having less affinity for keeping this reactant on their surface. Due to their less affinity, this bond will detach, this bond will get break up, and this reactant molecule will be converted into product molecule and it will diffuse away. What are these? Product molecule. And this catalyst, which is now left all alone, will be regenerated. It will be regenerated for further process. Let's see it once more. First step is, this is your catalyst with free valencies. The first thing, that is, this is your reactant molecule. First thing that is going to take place is diffusion. Diffusion of reactant molecule towards the catalyst surface. After that, there will be adsorption, process of adsorption of reactant molecule. By the formation of loose bonds. Now this will change into a intermediate product. With the help of chemical bond which is formed between the reactant and surface of the catalyst. After the formation of intermediate product which is unstable, process of desorption of product molecules will take place. Why this process is going to take place? Because when the intermediate product was formed, it is considered as unstable in nature. That means the chemical bond which is formed here can break down, because the surface of the catalyst is having less affinity for binding the reactant molecule to its surface, due to which what will happen, this reactant molecule will get detached by breaking of the bond and product molecule will diffuse away. Product molecule will diffuse away, leaving the catalyst over here. This catalyst is regenerated. This catalyst is regenerated. So this is the mechanism for the modern adsorption theory of catalysis. Let us now study about few important features of heterogeneous catalysis. Under this, we will be studying about three important features. First one is activity. Second one, selectivity. And the third one is specificity. First one is activity. Now what do you mean by activity of any catalyst? This is basically the extent by which any catalyst can enhance the rate of a reaction. Or we can say it is the capacity of a catalyst to increase the speed of a chemical reaction. That tendency, that ability is known as activity. So what is activity? Capacity to increase the chemical reaction, or we can say the extent up to which a catalyst can increase the rate of a chemical reaction. The other one is selectivity. Selectivity is basically the ability of the catalyst to direct the reactant molecule. Ability of the catalyst to direct the reactant to form particular products. Let's take example of this. If we talk about carbon monoxide and H2. Now this carbon monoxide and H2 can react in the presence of different catalysts to give different product. For example, CO plus H2 can give you formaldehyde in the presence of copper, whereas CO plus H2 can give you CH4 plus H2O in the presence of nickel. Hydrogenation reaction in the presence of nickel. So in these two examples you can see CO and H2 can lead to the formation of different product on the basis of the catalyst that is used. So here what is the work of this catalyst? It is having the tendency to direct, it is directing the reactant to give a particular product. The next one is specificity. specificity. It means that catalysts are basically specific in nature. It is highly specific in nature. That is, a given substance can act as a catalyst only in a particular reaction and not for all the reaction. So, by this we can say catalysts are specific in nature. Only one catalyst can be taken in any particular reaction. It cannot act as a catalyst in all the reactions. The next topic is about zeolites. Now, what are these zeolites? These zeolites are aluminosilicates. These are aluminosilicates. They are basically microporous, having 3D network of aluminium, oxygen and silicon framework. Which is arranged in a honeycomb-like structure. If it is asked in 1 mark question that what are zeolites, you need to mention these points. Now these zeolites, a very important feature of zeolite is it is known as shape selective catalyst. Now why it is known as shape selective catalyst? Because these zeolite, they have, when they act as a catalyst, they have free valencies on their surface. And not every reactant is having the tendency to come and bind to its surface. They are quite selective in nature. So the reactant molecule which can fix to the surface of zeolite, there only the combination of the reactant and the catalyst can be done, and in that case only it can be used as a catalyst. That is why it is known as shape selective catalyst. Due to the presence of active sites on its surface, it is known as shape selective catalyst. Now, what are the applications or what are the uses of this catalyst? Zeolites. These zeolites, in class 11th you have studied about resin ion exchanger. In that resin ion exchanger, zeolite is used as a catalyst for 2 purposes. First one, for the purpose of purification, and another one for the softening of water. The zeolite is also used in petroleum industries. For the process of cracking of hydrocarbon. And it is also a very good adsorbent. So these are the uses of zeolite. Question can come on this topic, and just to write a brief account of zeolite, that is shape selective, catalyst. In that type of question, you need to write down all these points. Now let's talk about enzymes. Now what are these enzymes? Basically all the biological reactions, they are catalyzed by a special kind of catalyst which is known as enzymes. That is why they are also known as biochemical catalyst. We can say that catalysts which are used in biological reactions, that is the reactions which are carried out within our body or within any living organism, all the metabolism such as digestion, respiration, excretion. So whatever catalysts are used in those metabolism, they are known as enzymes. There are many examples for the conversion of starch into maltose. Dietase is used for conversion of maltose into glucose. Maltase is used for converting protein into peptides. Peptides are used for converting into glucose into fructose and sucrose. Invertase is used. So like this, there are many examples of enzymes. Now what are the characteristics of enzyme? First one is, enzymes are highly specific in nature. Specific in nature means each enzyme can catalyze only one chemical reaction, not more than that. Next one is, it is highly efficient in nature. Enzymes are very efficient in nature. They speed up the rate of reaction to a great extent. Even a very small quantity of enzyme can be highly efficient in nature. The next one is optimum temperature and pH. Optimum temperature and pH means the temperature and pH at which the rate of these enzymes are higher, or you can say the rate can be enhanced. So the optimum temperature at which any enzyme can work at a very good rate is approx to 298 to 310 Kelvin, and optimum pH is of about 5 to 7. The next factor is, or the characteristic is, coenzymes. Now what are these coenzymes? These coenzymes are the substance which are used in a chemical reaction to increase the activity of certain enzymes. They are known as coenzymes. The activity of enzymes is increased in the presence of a substance which is known as coenzyme. which is known as coenzyme. Now we are going to talk about the mechanism of enzyme catalysis. That means how the enzyme is going to get attached to the reactant. And the mechanism that we are going to learn is known as lock and key mechanism. So we are going to talk about lock and key mechanism. This is the mechanism of enzyme catalysis. Now, we all know that enzymes are highly specific in action, and it is due to the presence of some specific regions which are known as active sites. And these sites are associated with some functional groups which form weak bond with the substrate molecule. Let's see how it is done. This is an enzyme. And what are these? These are active sites present on the surface of the enzyme. And this is a substrate. Enzyme and substrate. Now this enzyme acts as a catalyst and substrate act as a reactant. Now what happens when this substrate comes and binds to the surface of this enzyme, that is in its active site? It leads to the formation of enzyme substrate complex. Enzyme substrate complex. Enzyme substrate complex. Once this enzyme substrate complex is formed, that means once this proper orientation has been achieved, the substrate molecule, it start reacting with the enzyme to form the product. And this is known as enzyme product association. Since the product which is formed here, it do not have any affinity for the enzyme surface. So what happened? The product which is formed, it start leaving the surface of the enzyme and make itself detached from the enzyme molecule. This is your product. Enzyme and product. Let us see it once more. This is your enzyme which act as a catalyst, substrate which act as a reactant. These are the active sites on the surface of the enzyme which are associated with some functional group on their surface. and due to which it leads to the formation of weak bond with the substrate when it comes in contact with the surface. After that, it leads to the formation of enzyme substrate complex. That means the active sites which are there, it is occupied by the substrate. It goes and binds into the active site and leads to the formation of enzyme substrate complex. Now, once the proper orientation has been achieved, that means once this binding is done, the substrate molecule, what they do, they start reacting with the enzyme to form the product and leads to the formation of next association, which is known as enzyme product association. And when this enzyme product association is formed, now the product, once it is formed, these products, they do not have any affinity towards the enzyme, so they start detaching themselves from the enzyme, which leads to the separation of enzyme and product. Okay, so the first step, let us summarize it. The first step was formation of enzyme, I am writing it in short, enzyme substrate complex. That is, enzyme plus substrate will give you enzyme substrate complex. After that, dissociation of enzyme substrate complex to form the products. This is an enzyme substrate complex which will dissociate into enzyme product association, which will further lead to the separation of enzyme and product. So this was all about lock and key mechanism for the enzyme catalysis. In the next class, we'll discuss about colloids and we'll do a detailed study of colloids. Thank you.